So what is a linear equation? Well, those are the two forms that I was talking about that we have. So the two forms that we have are standard form and slope-intercept form. So we typically like the standard form best. That's our most favorite form to use, right? Because it lets us look at, why is that not working? It lets us look at equations that we can graph with the beginning point and the slope. So the first thing that we're going to do is just identify every equation that is a linear function, meaning that what does linear mean? No, if I have a linear equation, what does that mean? Catherine, give me your phone. What does that mean? It means that the graph makes a straight line. Yeah, the graph makes a straight line. So a linear function, the graph is a straight line. That's what linear means. The graph is a straight line. So I want you to look at each equation, and we're going to compare it to the two forms up here. We're going to see if it looks like standard form or see if it's written in slope-intercept form, or maybe it's not written in either form. So example A, Austin, what do you think? Well, we could, but we're not going to. You should be able to look at them and tell. What do you see about example A? Yeah, this is standard, so it's linear. I'm just going to write standard. So that means it's linear. It's in standard form. Okay. What about example B? Yeah, this is in slope-intercept form. So I'm just going to write slope, and it is linear. What about example C? What kind of an equation is that? We spent a lot of time working with those. Any ideas? Huh? It's none of them, yeah. We should know what kind of an equation this is. We spent a lot of time with this. It's a quadratic. It's a quadratic function because look at what's happening to x. It's being squared. This is a quadratic function and it is non-linear. Quadratics make a parabola. Quadratics make a parabola. What about example D? What do you think for example D? What's different about example D and C compared to all the other equations that we've looked at so far? It's one step. Okay, what were you saying, Logan? Yeah, this is raised to a power, right? This is raised to a power. It's raised to the third power. So this is actually a cubic function. This is also nonlinear. This is also nonlinear. So maybe here's what we need to know, that x is to the power of 1 and y is to the power of 1. If we're going to have a straight line, the x and the y don't have any powers on them, right? Because we don't write anything to the power of 1. They have no exponents. So let's look at example E. What do you think, Austin? You think it's linear? You think it's in standard form? What's x times y? How many degrees, how many powers are there? Well, we add those two together. This is to the second degree, so this is also nonlinear. It's not any type of form. This is just nonlinear. So remember, you cannot have any kind of exponents or products. You can't multiply x and y either. You cannot multiply x and y either. What about example F? Well, F is written in slope-intercept form, so I'm going to write slope. And this one is linear. What about G? Yeah, it's nonlinear. Okay. What about H? This is linear. Do you know what kind of line that makes? Good job. This is a horizontal line. We spent a lot of time with that semester one. What about example I? The graph does make a straight line, but it's not a function. This is the equation to a vertical line. This is a vertical line, but it's not a function. Can anyone tell me why this is not a function? Say that again. I'm going to write does not pass the vertical. What am I filling in? Does not pass the what? The vertical line test. Good job. Does not pass the vertical line test. Yeah, remember, in order for something to be a function, it has to pass the vertical line test. And a vertical line will not pass the vertical line test. This last one is a function. It's also written in the slope form. So this is linear. So I'm going to leave that there for a second. Again, these should be review. These should be review. So it says, how do you graph a linear equation? Well, if they're in standard form, you use the intercepts, right? You plug in 0 for x and you plug in 0 for y, and you find the x and the y intercepts. If they're in slope intercept form, you find the b, because that's where you begin, and you count your slope. You could draw a quick table, and we're going to do that today, but really a better method is to find b, and that tells us where to begin on the y-axis, and then count your slope. Do you guys remember doing that over and over and over again? So in the form y equals mx plus b, b is where you begin. It's your y-intercept, and then you count your slope from that point. Okay. Again, this should all be review. This should all be review. So I am going to go to the next page, and we're just going to graph the same equation, but we're going to write it two different ways. We're going to graph the same equation, but we are going to write it two different ways. Reese, are you good for me to go? Okay. All right. So this is the function that we're looking at. We're looking at this example, and we're going to try and put it in standard form. So it says we're going to plug in a 0 for the x and a 0 for the y to find the x and y intercepts. So let's first find the y-intercept. That means we let x equal 0. That's what that means. If you want to find the y-intercept, you have to let x equal 0. You have to let x equal 0. So 2 times 0, because that's where the x coordinate is, plus 4y equals 16. What is 2 times 0? 0. Yeah. So I really have 4 times y equals 16. Divide both sides by 4. And I find out that y equals 4. Okay. Now let's find the x-intercept. Let's find the x-intercept. So to find the x-intercept, I let y equal 0. So I have 2 times x plus 4 times 0 equals 16. 4 times 0 is, so I really just have 2x equals 16. What do I do? Yeah, divide both sides by 2, and I find out that x equals 8. So for the first one, to find the y-intercept, we let x equal 0. So that's the order pair 0, 4. And to find the x-intercept, we let y equal 0. So that's the order pair 8, 0. So I'm going to scroll down to that graph, and I'm going to graph my intercepts. I'm going to graph my intercepts. So I'm going to go down to the graph. So how do I graph the y-intercept, the order pair 0, 4? What do I do to graph the order pair 0, 4? Yeah, start at the 0, 0, the origin, and go up 1, 2, 3, 4. And I'm going to plot that point right there. How do I graph the ordered pair 8, 0? Well, again, I start at the origin and I go over 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8. And once you graph those 2 points, you just connect those points with a straight line. Put arrows on the end of it because lines go on forever. Put arrows on the end of it because lines go on forever. You need a ruler? They're up front. They're right next to those 3 white containers. So if you like push all those papers over, there should be a pile of rulers right there. Does anybody remember how I taught you guys this standard form? Do you guys remember what we called this method? Maddie, do you remember it? That's fine. We called it the cover-up method. I want to show you why. We call this the cover-up method, right? Because if you want to find out where your graph crosses the y-axis, just cover up the x term. Because multiplying by zero is the same thing as getting a 0, right? So I have the equation 4y equals 16, which means y equals 4. Plot that point. Then if I want to find the x-intercept, I cover up the y term. 2 times x equals 16. Divide both sides by 2, x equals 8. We call this the cover-up. So that way you don't have to plug all those in. You just cover each side up. Do you guys remember doing that if you had me last year? I think that Mrs. Melby teaches it that way as well. I think she calls it the cover-up. Maybe not. But cover-up method. Okay. So does everyone have those graphed? That first equation is graphed for you? All right. Let's go to the next one. So for this equation, we are going to solve for y. We have to get y all by itself. So what do I have to do first? Trying to get y all by itself. What do I have to move away first? So how do I do that, Logan? Yes, sir. Subtract 2x from both sides. So that gives me 4y equals negative 2x plus 16. Still trying to make it look like y equals, not 4y equals, just y equals. Yeah, divide every stinking term by 2. every single term, not by 2, sorry. By what? By 4. Yeah, divide everything by 4. You divide by the number attached to the y. So that gives me y equals negative 2 divided by 4 is the same thing as negative 1/2 x. 16 divided by 4 is 4. 16 divided by 4 is 4. So we could fill out a table of values. Absolutely. We could plug in, this says let x equal negative 4. So y equals negative 1/2 times negative 4 plus 4. Well, what is half of negative 4? Or what is it? Yeah, but a negative times a negative is a positive. So 2 plus 4 equals 6. So that says when x is negative 4, y is 6. Okay. Let's look at the next one. Let's plug in a negative 2. So that's y equals negative 1/2 times negative 2. Well, what's half of 2? Half of 2 is 1. And 1 plus 4 is, yeah. Let's let y equal, or let's let x equal 0. Let's see, that gives me y equals negative 1/2 times 0 plus 4. What's anything multiplied by 0? So 0 plus 4 is 4. And we could keep going and going and going, but hopefully you notice a pattern in your table. What is the pattern? They're going down by how much each time? They're going down by 1. So I know that this next one is going to be 3, and the one after that is going to be 2. Okay. So we have 5 ordered pairs that we can graph. We have 5 ordered pairs that we can graph. And I'm going to wait for you guys to catch up. So remember that these numbers in your table are just ordered pairs. These numbers in your table are just ordered pairs. So the first number I'm going to graph is the ordered pair negative 4, comma 6. So I begin at 0 and I go back 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. Negative means go to the left. Positive means go up or down, right? So negative is left or down. Positive is right or up. So I have a negative x and a positive y. So negative 2, 5. I'm going to go back 2 and up 1, 2, 3, 4, 5. Okay. And then my next one is the ordered pair 0. Let x equal 0. Well, that's right on the y-axis. Go up 1, 2, 3, 4. And then I have the ordered pair 2, comma 3, and they're both positive. So when x is positive 1, 2, y is 1, 2, 3. And the last one, when x is positive 4, 1, 2, 3, 4, y is positive 2. So once I get all of my points graphed, I'm going to connect my points with a line. And remember, when you make your line, you want to go through the ordered pairs. You're not just connecting them like a dot to dot. Okay. You want to go through all of the ordered pairs. How many of you guys remember doing this? Yeah. Hopefully all of you remember this, right? Okay. Madeline, do you remember this? Graphing? No? No? Okay. So raise your hand if you still need more time for this. Raise your hand if you need more time. Okay, so I'm going to the next one. Here we go. So we're going to start with the equation y plus 3 equals 2x. And it says get y by itself. Get y all by itself. So what do I have to move away? Brian, what do I have to move away from the y? What do I have to move away so y is all by itself? Look at the equation, Brian. What do I have to move from the y? If I want this to be all by itself, what do I have to move away? Yeah, that positive 3, that plus 3. So what is the inverse or the undo of plus 3? Yeah, minus 3. Whatever I do on one side, I have to do to the other. And that leaves me with y equals 2x minus 3. Y equals 2x minus 3. So I'm going to let x equal -1, 0, 1, and 2. Those are the values I'm putting into my table. So we're going to solve for y. So if I let x equal -1, that gives me 2. I'm using this function right here. 2 times -1 minus 3. Put it into your calculator. What is 2 times -1 minus 3? It is -5. So that's the ordered pair, -1, -5. -1, -1, 2, 3, 4, 5, plotted right there. That's this point right here. Okay. What about when x is 0? Well, that's 2 times 0 minus 3. What is 2 times 0 minus 3? It's -3. Okay. So when x is 0, y is -3. That's this point right here. What do you notice, Reese? Sorry, not Reese. Yeah. What do you notice, Reese? Do you notice anything yet? Do you notice a pattern? Let's do one more. 2, I see your hand, Austin. 2 times 1 minus 3. What is 2 times 1 minus 3? It's -1. So when it's going down by 2, yeah, when x is +1, y is -1. So I have plenty of points that I can actually connect my lines. So does anyone remember doing this? You guys see what I'm doing? I'm drawing little triangles there. To go from one point to the next, to go from one ordered pair to the next ordered pair, to go from here to here, how much am I going up and how much am I going over? I'm going up 2 and I'm going over 1. 2 over 1 equals 2. And that just so happens to be my slope, right? And you guys had a review, you had a spiral review, your 13, 14 week spiral review was on slope. So if I know my slope and I know where I cross the y-axis, which is right here at -3, I could actually not fill out a table of values, but instead begin at -3 and go up 1, 2 over 1, plot a point, do it again. Up 1, 2 over 1, plot a point, do it again. Up 1, 2 over 1, plot a point, do it again. Up 1, 2 over 1. Do you guys remember doing that? Yeah. Madeline, pick your head up, please. You're sleeping. Zach M, I think you're sleeping on me. So that's really all we're doing. We learned how to fill out a table of values, but we also, more importantly, learned how to identify the slope and the y-intercept from an equation. Kimber, are you reading the back of your eyelids? Come on, open them up. Okay, so you guys know how to do that. You know how to do that. I don't want you to resort to filling in a table of values unless that's the question. Fill in the table of values. Otherwise, use what you know. Yeah, I drew that on the board. You're exactly right. So my slope is 2 and my y-intercept is -3. The y-intercept is where you begin on the y-axis. Your slope, we always write as a fraction, and this is how you count it. Up, and we always run to the right. Now, if that top number was negative, we wouldn't go up, we would go down. Yep. All right, so we're going to talk about why is it important to get y all by itself? Why is that important? Well, x is independent. We determine what x we're using. The value of y depends on x. That's why, because the value of y depends on the x, right? So if we get y all by itself, we can choose any x value and determine our output. Remember that x is also called on input, the number that you put in, and y is the output, the number that you get out. And that happens when you solve for y. Okay. We're going to skip A, B, C, and D. We're going to skip A, B, C, and D. Can you wait 5 more minutes? And then I'll get you out of here for a bathroom break. We're going to skip A, B, C, and D. And on the next page, we're going to take these 3 equations and we're going to solve them for y. We're going to solve them for y and then graph using y equals mx plus b. So this is kind of what we're going to model. Y equals my slope times x. So this is your slope plus b, which is where you begin, on the y-axis. We've written this. This is the 4th time that we've written that. Okay. So let's look at this equation right here. And someone tell me what my slope is. And someone tell me what my y-intercept is. So Hayden, what is my slope? It's -3. X is not part of slope. Okay, Hayden? So it's -3. How do we want our slope written, Hayden? We like our slope to be written as a what? So we can count how much we rise over how much we run. I heard someone say it. Yeah, we like it to be written as a fraction. So -3 is the same thing as -3 over 1. You want to write it as a fraction. And what is my y-intercept? Austin? It's 8. So we're going to go to the y-axis and we're going to begin at +8. This is where we begin on the y. So 1, 2, 3, 4, 5, 6, 7, 8. Again, this should be review. This should be review. Okay. Now my slope, that top number is negative. That top number is negative. So does that mean I go up or I go down? I go down. And we always run to the right. So from this point that you just plotted, you need to go down 1, 2, 3, and to the right 1. Do it again. Down 1, 2, 3, and to the right 1. Do it again. Down 1, 2, 3, and to the right 1. And again, down 1, 2, 3, and to the right 1. So once I have quite a few points, I'm going to connect them with a nice straight line. And I don't even worry about filling out my table because I don't need it. Okay, so for B and C, we're going to get Y all by itself, and then you guys are going to graph it. For B and C, we're going to get Y all by itself, and then you're going to graph it. So if I wanted to get Y all by itself, what do I need to do first? What do I have to do? Yeah, I need to distribute. So I still have Y minus 6 on the left side equals, let's see, negative 3 times X is negative 3X. Negative 3 times 2 is negative 6. And then what do? Still trying to get Y all by itself. Yes, sir. I'm going to add 6 to both sides. Plus 6, plus 6. So Y equals negative 3X plus 0. Do we typically write plus 0? Nope. But it's sometimes helpful to let you identify what your slope and your y-intercept is. So CC, what is the slope of my graph as a fraction? Yes, it's going to be negative 3, and I want it as a fraction, so I'm going to write it over 1. Daniel, what is my y-intercept? Where does this cross the y-axis? What's the b value? It's, yeah, do you know what that's called? It's called the origin, right? So my y-intercept is at 0. So Daniel's saying go right to where the two graphs intersect because that's where y equals 0. And then that's where I'm going to begin. This is, remember, where you begin. Begin on the y. It's where you begin on the y every single time. Begin on the y. So I'm going to begin at 0. And then my slope is negative. Does that mean I'm going to go up or go down? I'm going to go down. Down 3 over 1. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Connect my lines, or my points, sorry, with a nice straight line. Okay. Connect your points. What if you can't go down anymore? Do you guys remember how that works if you can't go down anymore? If m equals negative 3 over 1, and that means go down and to the right, and I can't go down, what if I move that negative to the bottom? That means I go up and to the left. So from here, I could go up 1, 2, 3, and to the left 1. Up 1, 2, 3, and to the left 1. Do you guys remember doing that last year or last semester? Well, it was last year, but yeah. Okay. Last one, and then I'm going to get Zach to the restroom. Last one, and then I'm going to get Zach to the restroom. Okay. We're going to solve this for y. Solve for y. What do I need to do first? Trying to get, say again. Yeah, I'm trying to get the y all by itself. So what do I have to move away? Yes, thank you, sir. Subtract 8 over 3x from both sides, minus 8 over 3x. So this cancels out, and I'm left with negative 4 over 3y equals negative 8 over 3x minus 4. Yeah, what's that called? Yeah, we have a fraction coefficient. So we multiply both sides by the reciprocal, and we multiply every single term by -3/4. That means that I'm going to multiply this by -3/4, and I'm going to multiply this by -3/4. Every term. So these cancel out, and I'm left with y equals -3 times -8 is positive 24. 4 times 3 is 12x. -4 times -3 is a positive 12. And 1 times 4 is 4. Can I simplify that? What is 24 divided by 12? So 2x. And what is 12 divided by 4? Plus 3. That positive 3 is where I begin. Yeah, I'm really struggling spelling begin today. Has anyone noticed that? Every single time. Begin. So positive 1, 2, 3. Begin on the y-axis. And then what is my slope? M equals 2. If I write it as a fraction, it's 2 over. That means I go up 1, 2 over 1. Up 1, 2 over 1. Up 1, 2 over 1. If I can't go up 2 anymore, can I go, what else can I do? Go down and to the left. Down 1, 2 to the left 1. Down 1, 2 to the left 1. Down 1, 2 to the left 1. Okay. So we're going to stop there. We'll finish that last page tomorrow. We're going to stop there. We'll finish that last page tomorrow.